What we're going to talk about today is patterns that exist in math and whether we can develop rules for such patterns, which is something we like to do quite often in math because rules allow us to figure things out, make generalizations, and other types of very useful strategies. So we're going to take a look at these five sequences of numbers and figure out if there's a pattern. And if you take a look in the first one, we're adding 3 to each number. In the second one, we're multiplying each number by 2. In the third one, we're adding an amount to each one. And what we're doing is we're increasing by 1 how much we're adding to each one. In the next one, we're adding the odd number that falls into that place. And in the last one, we're subtracting 3 from each number. So those are various patterns. And what we like to do is work with today what's called an arithmetic sequence, which is a particular type of pattern where we can then figure numbers farther out in the sequence very easily. So a sequence is simply an ordered list of numbers that often form a pattern. The term of the sequence is just each number in the list. And we're going to talk about this sequential numbering in a couple of minutes because it has a notation all to itself. An arithmetic sequence is simply a sequence in which the difference between consecutive terms is a constant. And now you'll hopefully understand why this whole topic is in linear functions. It's because the fact that this difference is a constant. And as we've been talking about, in linear functions, there is a constant rate of change. The common difference is just the constant difference referred to above. Now, if you go back and take a look at the 5 list above, which of them are an arithmetic sequence, and hopefully you'll see it's only A and E, because A, we were constantly adding 3, and in E, we were constantly adding -3, which is the same thing as subtracting 3. What you'll notice is that an arithmetic sequence is a linear function because of this constant difference. Now, let's make sure we understand some of this notation. Each term in a sequence is identified by what's called subscript notation. I'll show you what that means in a second. The general form is A sub n. The n is below the A. It's like the opposite of an exponent, where n represents the term number in the sequence, and A sub n is the value. Okay? So let's make sure we understand what this is saying. The number 7 is the first number, so we call it A sub 1. 11 is the second, it's A sub 2. 15 is the third, it's A sub 3, and so on. Okay? So 7 is what the value is of the first term. 11 is the value of the second term. Now, if I wanted to find A sub 9, well, one way I could do it is just continue on my pattern. My pattern is adding 4. So then A sub 7 would be 31. A sub 8 would be 39. And A sub 9 would be 39. That's all we're talking about. Okay? Now, using the sequence that we just had above, let's write each term as a function of the one immediately prior to it. So let's show you what we're talking about. The value of term 1, excuse me, A1 is 7. The value of term 2, which is A2, is A1 plus 4. The value of term 3 is A2 plus 4. Now, we're just going to continue on with this to show you that as we keep going, the value of each term is the prior term plus the common difference of 4. And if we continue this down, what we could do is we could say the nth term. And when we give a variable in math, what we're talking about is any term is equal to the number right before it. So n minus 1 means the number right before n plus the common difference. What we've just come up with is what's called a recursive formula. Okay? And what is a recursive formula? It's a formula to represent an arithmetic sequence as a function rule that relates each term of the sequence that's after the first term to the ones before it. The first term is always just given to you. That's our starting point. It has nobody before it. So, what is our recursive formula? A sub n, meaning any number in the term, is equal to the number right before it. That's what n minus 1 means, plus d, and d is my common difference. Okay? So now let's practice some examples here. Now, let's think about this. Suppose you want to figure out a term somewhere down the line in a sequence. And let's say we want to find the 50th term. All right? Now, let's take a look at the following. Going back to the sequence we had before. So I'll write that down here. 7, 11, 15, 19, 23, and 27, ... Okay? Well, we know 7 is A1, A2, A3, A4, A5, and A6. And we know D is 4. Our common difference is 4. Now, it's nice that we have this recursive formula, but let's say I want to find the 50th term. You should understand that in math, if we're asking you to find something that's either through a lot of calculations or far down the list, that there's going to be some sort of clever shortcut to do this. Because we don't want to list out the 49 numbers before the 50th. So let's see if we can come up with a formula. Excuse me. So let's examine this, and we're going to look at this two different ways. A1 is equal to 7. All right? And what you'll see here is every time we're adding 4. And if you understand that repeated addition can be translated into multiplication, that'll help you understand this. Now, what is A2 sub 2? Well, it's the 7 plus 4. Okay? Now, what's A3? It's 7 plus how many 4s? 2 of them. So it's 7 plus 2 times 4, right? What is A sub 4? It's 7 plus how many 4s now? 3 times 4. Well, hopefully you're going to see where we're going with this. And A sub 6. Now, what you want to try to do is look at this pattern and come up with a general rule for A sub n. Okay? Because the givens are, we know the first term, we know where you lie, if you're the first, the second, the third, the fourth, and we know our common difference. Well, if you're looking, what you'll see is the number I multiply the common difference by is always 1 less than where I am in the order. So how can I write my rule? My rule is any number in the sequence is always the first number, A sub n, plus 1 minus, or 1 less than where I am in the sequence, times my common difference. Okay? All right? So, how would I find A sub 50? Now I can go back and use this rule to say A sub 50 is equal to 7, my first number, times 50 minus 1. I'm in the 50th number. Or 7 plus, 50 minus 1 times my common difference. So A sub 50 is equal to 7 plus 49 times 4. Okay? So, again, all I'm doing is now being able to write a rule that will allow me to find any number in this sequence without having to find all of the other ones before it. It's 49 times 4, which is 196. So the 50th number in this sequence is 203. Okay? What we have just figured out is what's called the explicit formula for an arithmetic sequence. And what that is a function rule that relates each term of a sequence to the term number. In other words, I don't need to know the numbers before it. All right? I don't need to know all those numbers before it. All I'm going to need to know for this formula are 2 things. For this formula, so to find any number, I need to know the first number in the sequence, and then I need to know what my common difference is. Okay? So, let's practice with a couple of these. Oh, orientation's a little off, so I apologize. Now, you are going to have to know these formulas. Unfortunately, there's no way around it. So, I look at this sequence, and I see that D is 5, and I want to find the 20th number. Well, how would I do that? The formula is, and I'll put it up here, AN equals the first number plus n minus 1 times D. The first number in my sequence is 3. N minus 1 is 20 minus 1. D is 5. So the 20th term in the sequence is 98. Now, it's not that far out that you can check it, but I need you to be comfortable with what you're doing with the formula. All right. An arithmetic term is represented by the recursive formula here. If the first term is 19, write the explicit formula. Well, this recursive formula tells us that D is 12. And I'm telling you A1 is 19. So now I can write A9, A for any value is the first term plus n minus 1 times the 12. Okay? Now I give you the explicit formula. The explicit formula tells you that A1 is 32 and that D is 22. Okay? The recursive formula is the number prior plus the common difference. It's as straightforward as that. All right? And let's go to the last example. A subway pass has a value of $100. After one ride, it's $98.25. After two, it's $96.50. Write an explicit formula. All right? A sub 1 is 100, and D is negative 1.75. Remember, your difference, common difference, can be positive, it can be negative, it can be fractions, it can be decimals, it doesn't matter. Okay? So, the explicit formula, A sub n, is 100 minus n minus 1 times negative 1.75. Why is it minus? Excuse me. Because, and let me just change one thing. Not a double negative here, 1.75. It's a minus here because the 1.75 is minus. Now, if you made this a plus, if you change this to a plus and change that to a minus, it would have the same impact, okay? So to find after 15 rides, okay? So now I have to just do the math. And I should write this A sub 15, 100 minus 14 times 1.75. So there is your value. So, an arithmetic sequence is a way of writing, is a representation of numbers that have a common difference, and we can turn arithmetic sequences into formulas that allow us to figure out numbers somewhere in later down in this sequence.